Hi, everyone. My name is Jasmine Cameron. And reminder, please mute yourself. My name is Jasmine Cameron. I am the co-chair of IPAC Manitoba. And today is our introduction to data manipulation in R. First, I'm going to start with a land acknowledgement. IPAC Manitoba is located on the ancestral lands of the Anishinaabe, Inninawak, Nishinawak, Dakota, and Dene, and on the homeland of the Métis Nation. We acknowledge the distinct histories of the 7 numbered treaties that apply to this land. We recognize that public administration and public policy have been used as tools of colonialism, and that the harm that this has caused Indigenous people. We are committed to promoting public administration in a way that advances reconciliation in a spirit of collaboration with Indigenous people and communities. Our speaker today is Matthew Cook, who is a senior data scientist in the government of Manitoba's data science program based in the Department of Labor, Consumer Protection, and Government Services. He is currently finishing his PhD in the brain and cognitive sciences area in the Department of Psychology at the University of Manitoba, where he has taught our workshops to undergraduates, graduates, and faculty members. I will now hand it off to Matt. Thank you very much.
Thank you very much for the introduction. Yeah, that's great. I'll go ahead and share my screen here. Let's see. So if you're following along and you open up R, you should have something like this in front of you. You should be able to have RStudio open like this, and you start off with this sort of some copyright information about the version of R and that. So I encourage you to follow along, and I think that this workshop is really important because if you've followed along with sort of our initial workshops, the introduction to R or the data visualization, you've gotten your feet wet and you can work with data and you can summarize data and visualize the data. But often a really big problem happens when you go to use real world data sets that are maybe messy, or they have, maybe they're not structured in quite the right way for what you're trying to do in R. And, you know, to be honest, in those first workshops that we worked, when we worked through these examples, I always chose the data set that would sort of be the best example of how to get started. So if we were making a plot, you know, I chose a data set that was always nice and clean and organized and structured in just the way that we wanted it to be. But if you've tried using R with maybe a different data set or your own data, you know, at that point you might have cursed my name because you realized that there was some mismatch between the way that the data was in R and the way you needed it to be to get to work with that plot or to summarize it in the way that you wanted to. So in these previous workshops, I've always used that data that sort of was the best example of how to get started easily. If we're going to make a plot, I chose a data set that was structured and cleaned in the way that it would need to make that plot. In this workshop, it's going to be a little bit different. We're always going to kind of start with a data set that's always kind of the wrong data set, either because it's a bit messy or because it's in the wrong structure that we would need for making a particular plot or doing a particular summary. And even though, you know, this introduces frustrations, this is more realistic of how working with data in any programming language or any program goes. But when you're working with R, it's nice because there's these nice set of tools for cleaning up the data or for reshaping the data to work with the tools in R that we want to. So we'll get started here. So I'm just going to go ahead and open a new R script here. If you're following along, you can just click this little button here and click R script. Now we have a place to type our code and have it saved. So the first thing I'm going to do is load the tidyverse set of packages. So this is the set of packages we've been using since the very beginning in this series of workshops. And to do that, or to run this, I'm just going to highlight it and click run. Or if I have my cursor anywhere on the line, I can click Control Enter. And it might take a second to load up the packages here, but we'll see some information of the packages it loads. So, you know, ggplot2 and the visualization workshop, we talked about that. And there's these other packages in here that it loads, mainly to do with data cleaning and data manipulation. And if you don't have this package installed, you'll have to install that I'll just quickly show you here, install.packages and tidyverse. And I won't run this because I don't want to reinstall that set of packages. And the other package I'll just quickly install or load is the Gapminder package. And we've seen this in these first two workshops as well. It's just a package that has a couple data sets. One of them is called Gapminder, the same name as the package here. And that's the data we'll use a fair bit in this workshop, but there's another half dozen or so data sets we'll take a look at in this workshop. And again, always kind of choosing the wrong one for the thing we're trying to do. So I'll just maybe spend 10 minutes or so reviewing some of these core data manipulation functions that we went over in some of these initial workshops. And we'll see how we can vary them a little bit to do some more complicated things. But I figure it's probably good to just remind ourselves of where we're at now. So we'll start off with this Gapminder data. And if we type in Gapminder and click run, or again, just have our cursor somewhere and click Control Enter, we will see what we're working with here. So I'll just move this up a little bit. So, well, here, I'll just scroll down. But so, you know, we have this table here, or this tibble in our, and we have 1,704 rows and 6 columns, and we can see the column names here. And we can start to work with this data and manipulate it in some different ways. So one of the ways we might want to manipulate the data is just to get rid of some columns that we don't need, or to select columns that we want to work with. So we'll use this operation here that we've talked about several times now, called the pipe. And all this is going to do is pass whatever's on the left-hand side of this pipe to whatever on the right-hand side. So if I type in select country, what we're doing is we have this function here called select, and we're selecting the variable or the column country, and we're using this data set Gapminder. So we're passing this into the select function. So when we say country, it knows that we're talking about this data set Gapminder. And I'm just going to go ahead and put this on another line here just because I like the way that looks, and it kind of keeps everything to the left. So if I run that, we see that sure enough, what that's done is just selected out that column. And I can include other columns if I separate them by a comma here. So this would select just the country and continent columns. And if I want to, I'll just copy and paste this. I can keep every column except a particular column or several columns. So if I put in a minus sign in front of country, that's going to return everything but country. And this can be helpful because sometimes you have so much data. Maybe you have 50 or 100 or more columns of data, and you really just want to narrow in on the ones you're interested in. So using select can make that more efficient so that you're only looking at those columns that you want to see. We'll just quickly go through some other things here. So let's say we had our Gapminder again. Another thing we can do in addition to selecting the columns we want is to rename them. So let's say I want to rename, this life expectancy here to life _ expectancy. I can do that. Oops, just had a typo, rename. So if I run that, we can see that that's allowed me to rename that column. And that can be helpful because sometimes column names can be really long or have weird characters in there. And by renaming them, it lets you work in a little bit more easy way. Another thing that's a common thing you might do is change this to a more sort of human readable name if you're generating like a report or a small summary table or something like that. So if you want to have a more readable name with a combination of different characters like spaces and that, what you want to do is just wrap that in these quotes like this. And if we run that, we see that we get this, more readable name without underscores and that kind of thing.
20 minutes, Pacha.
Just gonna make someone. Okay. So those are two common functions. Another one that you might use quite a bit is arrange. And this just lets you sort or arrange different columns or variables. So if we arrange it by life expectancy, we can see we've sorted it from lowest to highest. We can also, if we want it to go from highest to lowest, we can just wrap this variable in this function here called DESC for descending. And if we run that, we see now it's sorted by from lowest or from highest to lowest. And we could include other columns in there too. If we wanted to, you know, break ties by year, we could do that. So you can sort by multiple columns. And again, that can be helpful for just looking at the data and getting a sense of what's going on. Another function, and there's a couple more that we'll look at just as to remind ourselves. But the next one is mutate. And this we'll see a lot of examples today. And this lets you mutate or change or transform a column or a variable. So let's say that, you know, for life expectancy, we wanted to increase the life expectancy by 10%. We could do something like this. And what we're doing is we're saying we want to use the Gapminder data set and we want to mutate the column life expectancy. So we're going to get a new column called life expectancy, even though we already have one called life expectancy. And we're going to multiply that by 1.1. So we're going to basically increase this life expectancy by 10%, right? So if we needed to do that for some reason to, you know, if you had a column of prices and you needed to, you wanted to generate a new column of the after-tax price or something like that, you could multiply by 1.13 or whatever it is to get that new column. And here, in this case, I'm just sort of copying over this life expectancy column, but I could, you know, make a life expectancy 2 column or something like that. And when we run it, sure enough, we see that we get that new column there, and it's just the original life expectancy column multiplied by 10%. And we'll see some examples, some more realistic examples of how you would use this mutate verb or this function to change your data set in useful ways. The other one that we'll quickly talk about, and I'll go through these pretty quick because I don't want to spend too much time as review. But another thing you can do that you need to do all the time when working with data is to filter the data or get rid of some rows based on some conditions. For that, we use this function filter. So let's say that I only wanted to look at the rows of this data set that were from Canada. So to do that, I could say, well, I want the country equals Canada. And we use this double equal sign in programming, and that just tests for equality. We use single equal signs when we're naming things and that sort of thing. But we can see we have 1,704 rows in the data set, but when we filter so that we only have where country is equal to Canada, now we only have 12 rows. So you can use filtering to check matches for strings like this if you're wanting to check for a particular or use a particular country or continent. And you can also do the same thing for numeric variables. So if you only want data where the life expectancy was over 80 years or over 80 or equal to 80, you can do things like that. And if this feels unfamiliar to you, that's okay. I would recommend just going back to that first workshop that's recorded on YouTube there from iPad, and you can revisit these things in more detail. But we'll also work through examples today using some of these functions again to sort of refresh our memory. Two other last quick things we'll just look at as reminders because we'll be using these quite a bit today. Another thing you can do is count various columns that have categories. So if we wanted to count to know how often this continent, how many times the Americas and the Oceanic or Europe appears in this data set, we can use this function called count. So we can say we want to use Gapminder, we want to count the continent. And if we do that, we get a count of how often each of these continents appear. So Africa appears 624 times and so forth. Similarly, what we can do is if we're more interested in the numeric variables of this data set, so let's say we want to get an average of the life expectancy for this entire data set, what we can do is use this summarize function. So we can say summarize, and then inside the summarize function, we just tell the function that how we want to summarize this data. So let's say we want to calculate the mean or the average of life expectancy. We can do that just by saying summarize and then mean life expectancy. And if we do this, we see that the average life expectancy was 59.5 for this data set. So those are some of the main sort of key verbs or functions for manipulating data. But even with these in your tool belt, often it's still not enough. Data can just be messy, and it can also just be in the wrong format or structure for doing what you want to do. And we'll look at a lot of examples over the next hour or so. The last thing I'll show just as a reminder is this group by function. This group by function lets you use all of these functions we've just looked at, but it applies them at the level of individual groups. So for example, I'll just copy and paste this code here. So this gave us a summary of the average life expectancy across the entire data set. But what we might be interested in is to look at the average life expectancy, not across the whole data set, but within each continent. So to do that in between these two lines, if we just include this function here, group by, and say we want to group by continent, and you see that R is helpful as you start to type out continent, it drops this little drop-down menu for you, and you can select continent just by hitting tab or enter, and it'll select that for you. So if we use another pipe here, what we're doing is we're taking Gapminder, we're grouping it by continent, and then we're summarizing the mean life expectancy. So if we do that, what we get here is not just one number that represents the average life expectancy, but we get 5 different averages, one for each continent. And this is really helpful because most of the time you have some groups you're interested in. If you're an experimentalist, you might have your control group and your treatment group. If you're looking at data across Manitoba, you would have maybe different regional health authorities or different cities, you might have different grouping by different genders or that sort of thing. So this is something that you do very commonly when working with data. And as you can see in just a couple lines, we're able to summarize that data by the group, and it's very helpful. So that's a brief overview of what we covered in the first workshop, the introduction to our workshop, and a little bit of what we went over in the data visualization workshop too, for just prepping the data to visualize. But now let's get into some new things that, if you've worked with data in R, you might have come across, maybe you weren't 100% how to deal with these things. So let's take a look at this data set here that we haven't looked at yet. It's called Table 5. It's not a particularly descriptive name, but it has some data on tuberculosis. And we'll see why this is such a great data set for data cleaning, because when we look at it, we can see it has a lot of problems. So we see we have this country here, everything's fine with that. But one of the things that jumps out to me right off the bat is this rate column. So we see that it's not particularly helpful, right? We have these numerators, which are counts of the cases of tuberculosis in this particular year, and the population, right? But it's all in one column and it's separated by this comma here. It's sort of represented as a fraction. And this is not helpful to us at all because we can't do things like sort this column, right? These aren't numbers. We can even see here that R doesn't represent this as numbers. It's represented as a character or a string. So we can't do things like sort this in any meaningful way. We can't do math with this. If we wanted to, figure out which one of these numbers was the biggest, we can't do that. So what we have here is one column, but what we really want is 2. What would be nice is if we could split these numerators into one column and then have these denominators in another column. And then we could actually do things like, calculate what % of this number is of this number, and we can sort them and order them, make numeric summaries and plots, and do everything we want to do with it. So the question is, well, how do we split this up so we can actually use this variable in a meaningful way? So we'll introduce this new function here called separate, and it does exactly what it says on the tin. It separates one column into 2 or more columns. And again, you see that R is kind of helpful here. It brings up this little pop-up here to tell us what information it needs. But if I have my cursor in this function here, and I click tab, it'll also remind us what data we need. So the first thing it says is it needs data. Well, we already have given it the data by piping it into this function, so we don't need that. I'll just press tab again. The next thing it says it needs is a column. So this is the column we want to separate or to split. So we'll just split rate here. And then the next thing, if we put a comma and push tab again, the next thing it wants to know is, okay, what are the names going to be of these new columns that we have? And we're going to have two columns because we're going to split this up in the first part of the fraction here and the second part. So what I'll write here is a C, and we've seen this before, but I'll just write this out and then we'll explain it. So what I've written here is this C function that has two different things, and I've just written them in quotes. I've written cases and then a comma and then another one. And well, you know what? I put denominator, but we'll call this population. So what this is saying is it's going to take data table 5 here, and it's going to separate this rate column into two columns. One cases, and that's going to be what's on the left-hand side here, the 745 and the 2666. And then everything on the right-hand side of that slash, it's going to put that into population. So if we run this, we see that now we have exactly what we want, right? Before, I'll just scroll up, we had this fraction here that wasn't super helpful. Now we have two nice columns, so we can do things like order these columns, see which ones are bigger and summarize them or plot them and that sort of thing. Now, of course, some weird things have happened here, right? So we've lost our initial column, right? We don't have this rate column anymore, and maybe we want that, right? Maybe we want that at the very least so we can make sure that this splitting process occurred okay. So if we put a comma here and push tab again, we'll see we have some options here to make this function work a little better. The first thing we actually see is this separator column, and it says that this will tell R what to separate this initial column by. And you notice that even though we didn't give this, R did a pretty good job of realizing without us telling it to split this column based on this slash here. And by default, R is just going to split it based on any non-alphanumeric character. So if you have slashes or hyphens or spaces, it's going to split that for you. But you don't always want it to just sort of do its own thing. So sometimes it's good to be explicit, and we can say, you know, we want this separation to occur based on a /. And in this case, it's not going to change anything because R already did that for us. But it's good to be explicit in that way. The second thing we can kind of add here is we see that there's this option for remove. And what that's going to do is say whether we want to remove that first column or not. And maybe what I'll do here is I'll just kind of put this on another line here so it's a little easier. So if we set remove to false, and false is a special word in R when it's in all upper cases like this. And what that's saying is, you know, don't remove this initial column rate. So if we run this, we see that it keeps rate, and now we have our two new columns. And this is good, again, just for verification, we can see that this splitting or this separating process worked okay. The last problem we still have, though, actually, is we can see that R is representing each of these columns, this cases and population, as characters, right? So we want R to treat these as numbers, not as strings or as words, but as actual numbers that we can do math on. So there's one last option here that's really nice called convert. And basically, if you set that to true, R is going to try to convert these columns to numbers when they look like they're numbers. So if we run this with convert equals true, we see that now our columns are represented as integers or just whole numbers, which is what we want. So now we have these two columns that we can actually work with to do different things. Like, for example, if we want to mutate, make a new column, maybe we want to know what the percent of people in Afghanistan in this particular year, you know, what percent 745 is of the whole population. So what we can do here is say, let's make a new column, and we'll just call it percent or PCT. And what we want to do is take cases and divide it by population. And what I'll even do is I'll put quotes or parentheses around there and multiply by 100, right? So we'd expect to get a new column called percent. That's cases divided by the population times 100. And if we run all this, we see that we get exactly that, right? 745 is, you know, far less than 1%, you know, 3 thousandths of a percent. And we can see that, you know, the biggest the biggest percentage we have here is right here from Brazil in 2020 in this data set. So now we can actually do math, and if we wanted to make a plot of these numbers, or we wanted to have this as a summary, we can do that, right? So we started off with this one column, and now we've mutated and changed things to actually be useful for us. And again, this is something that's really common. Data is often represented in ways that aren't super helpful, and the separate function lets you work with that data. Another problem we have here is sort of the opposite problem we can see we still have. So, here with this rate column, we had one column that we wanted to be 2. With this century and year columns, we really have 2 columns that we would like to be 1, right? It's sort of an odd way of thinking about a year is broken up in its century and year. It would be more helpful to just have a year column that was 1999 and 2000 and so forth. So I'll just continue on with this example here. We'll add another pipe, and what we'll use is this function called unite, and this is basically the opposite of separate. And we can see here one of the things it wants is the column, and this is going to be the new column we want. So we'll call this one, we'll just call it year clean. And then the next thing we'll want is let's see here, unite. Oh, sorry. What we want to do here, what we want to do is for column, what we want to do is say which columns we want to unite. So we want to unite century and year. Let's see if this works. I might have made a mistake and I typed this out. Nope. Let's see here. I think we just want this to be not in quotes. Century and year. Let's see, does this work? Nope, made a mistake again. Okay, well, this is a good opportunity to look at this. So if we type in the question mark and unite, what we'll get is this little help page here. And clearly, I've forgotten exactly how to use this function, so this is good. If you scroll down at the bottom, it will give us a, oh yeah, perfect. So this is what we want. What we want to do is unite, and we want the column, this new column we want. So I was right to start off. I just made a mistake after that. So we want this to be like date clean. And then after that, you'll see these 3 little dots here. That's for the columns that we want for R to unite. So let's type in, let's just remind ourselves what this was, century and year. So if I type in century and year, what's going to happen here is R is going to join century and year together, form this new column called date clean, right? So when we do that, we can see that it worked exactly like we wanted here. It combined that century column with the year column, but we can see that it didn't do things in exactly the way we were hoping, right? It sort of inserted an underscore there, just like with the separate, where it's going to try to make some reasonable guesses as to what you want. But what we can do here is say, we want our separator to just be nothing. So if we put in a blank quote here, what we'll get is 1999. So if I run this, we'll see that it did exactly that, and it joined these up just the way we wanted to. Now we can sort of still see we have the same problem here, where this date here is represented as a character rather than as numbers. And we want these dates to be, or this year to be, represented as numbers for plotting and that kind of thing. It would be useful. We'll notice here that there's no convert option with unite. So what we'll do is we will just mutate this column. So what we'll do is we'll say mutate, and we want to mutate date clean. And what we're going to do is say as integer, and then date clean. So what we've done here is we're going to copy back over this date clean column, and we're converting this date clean column that is a character as an integer. So this function here called as.integer will just take a character or some other type of data representation, and it'll convert that to an integer. So now if we run all this, we'll see that now we have an integer. So now we could do things like sorting or plotting in the expected way, where 1999 is less than 2000, whereas when that's represented as a character, that might not happen in exactly that way. So that's one thing, or a set of functions that can help clean your data. And even though this data, this table 5 here was a relatively small data set, you could see that there was problems all the way along with how things were represented. And this little example here is a pretty realistic example of things that you might need to do with, honestly, almost every data set that you come across. Quite often there's just columns where data is joined in a column that you need to separate out. And there's often things that are in multiple columns that you need to unite together so that you can work with it. So the nice thing too is that even though this data set was, a comically small data set with only 6 rows and 4 columns, if we put another data set in here that had the same column types in that, even if that data set had 1 million rows and 1,000 columns, it would do these cleaning operations just the same. So it works with any size of data, and it really lets you prep your data in a way so that now if we wanted to do summaries or plotting, we could do that easily. So another problem that kind of occurs quite often when working with data, and we'll use the data set here, I think we used in the visualization workshop a data set called Star Wars, and it has a whole bunch of information about Star Wars characters. So there's Luke Skywalker, C-3PO, etc. And then a whole bunch of information on them, like their height, their mass, their hair color, and etc. So one thing that you might want to do is, often there are variables you need to do the work you need with the data that aren't in there yet. So this is, again, this kind of idea behind mutating. So let's say that let's say that we're doing an analysis and we're interested in, let's say, we're interested in the different species within Star Wars, right? So there's this column here called species, and let's just go ahead and count the species, right? So we count species, and we can see that there are 38 different species, but most of these species only have one instance, right? So that's not particularly helpful. If we wanted to study these different species, we might want to just focus in on a few of the biggest species, right? So let's look at what species were most frequent. So we can see that human occurred 35 times in this data set, and then most of the other species are not very occurrent, right? This one, droid, only appears 6 times. So maybe what we'd want to do is say, okay, what we really want to do is make a new variable that encodes whether that character species is human or something else, right? And in that way, we would be able to get summaries or plots or group by that new column that tells whether it's a human or not, right? So to do that, what we can do is we can use a set of functions for working with strings. So I'm going to, again, use mutate here, and we'll call this species. Oops. So we're going to make a new variable called species, and that will just copy over our existing species. And if you type in str_, there's a whole bunch of functions from this package in the tidyverse called string_r. And it's for working with strings or working for these character variables. And we'll see one that's really useful right here. So let's say we have, let's say we want to look for, what function do we want here? Probably want Str Detect. So if we look for Str Detect, what this is going to let us do is look to see which species have the word human in it. And this is really important because let's say that there was human, but there was also humans. What we can do is say we want to, within the column species, we want to detect the text human, right? And we'll see how this is useful in a second here. So if we run this, let's just see what we get. So, okay, so this is perfect. So now we can see that species we're not actually seeing. So this is a great time to use select. So let's just select out name and species here. Oops. We'll just keep the columns we need. Right, so this is perfect, right? So now we have, and you know what, we'll include. Yeah, okay, this is good. So we have name and we have species. And you see that what this string detect function has given us is it tells us by looking at species, which ones were human or which ones had human in that name of their species. So you can see that Luke Skywalker, his species was human. It says true here, C3PO was false, and so forth, right? So now if we wanted to, we could count species. And now we have basically two groups, right? We have the species that were not humans and the species that were humans, right? And we also have some NAs, and we'll talk about how to deal with those shortly. But now this lets us do something really, really useful. So I'll get rid of this here. So now if we were interested in, say, the average height between humans and non-humans in the Star Wars universe, maybe I'll just include height here, so we can see what we have here. So now we have three columns. We have the character, we have the species, whether they were human or not, and their height. And now what we can do is we can group by species. So this is just grouping by that true or false, essentially. And we can look at summarize, and we can say, what is the mean or the average height? And this is going to give us the average height by species, right? Oops, and this is actually really good. So we'll talk about these. We're going to talk about dealing with NAs in more detail, but the way to deal with this for now, we'll just, within this mean function, we will write na.rm equals true. And what that's going to do is remove the missing values so that it can actually calculate the mean. Because anytime there's an NA, R essentially tells you it doesn't know how to calculate that average because there's a missing value in there. So by including that na.remove and setting that as true, that'll allow you to calculate that. So if we do this, we'll see that what this tells us is that when the species is not human, the average height is 127 centimeters in this case. I know just from looking at the documentation of the data. And for species that were human, we get 177 centimeters. And the ones that don't have any species listed were 181, right? So the nice thing about this is that even though we didn't start off with a column that encoded whether the species was human or not, we can mutate that column, mutate it and get a new column that describes whether that species was human or not. And we can include other things in here, if we wanted it to be something else like a droid or whatever it is. We selected that down so that we only had the columns we were interested in. We grouped by species, and then we got an average height within each of those species. And this is something that you might do all the time. So we could change this just to show you a more realistic or another sort of realistic example here. I'm just going to copy and paste this and change this slightly. So let's say instead of being interested in species, what we're interested in is the Skywalker family, right? So Luke Skywalker. So what we could do is, rather than changing this, I'll just type this out. What we'll do is we'll make a new variable that says is Skywalker. And what we'll do is look and try to detect something in the name and see if it has Skywalker in there, right? So I'll just run this first line first so we can see how this works. And maybe I'll keep name is Skywalker and height. So if we run this here, what we're doing is we have this Star Wars data. We're creating a new variable that says, is this character a Skywalker? And to figure that out, we're using this string detect function. And all it's doing is looking at the name column and seeing if Skywalker appears in there. And if it is, it's going to put a true, and if it's not, it's going to put false. So if I run these first couple lines here, we'll see that this works perfectly, right? Luke Skywalker, true, C3PO, nope, there's no Skywalker in there, and so on and so forth. So now what we can do is, rather than group by species, we group by is Skywalker, which is just going to be true or false. And again, we can keep this summary here. And what this lets us do is look at the height differences, say, between the Skywalkers and the non-Skywalkers. And we can see that it actually comes out to the same, but maybe we're interested in the mass or something like that. I'll include mass in here. And you can see that there's a slight difference, right? So again, this is really important because often you don't have the variables you want to do the comparisons that you want to do. So using this str detect function allows you to look to see if a particular string variable has parts of it that you're interested in. And as you can imagine, the sky is sort of the limit for the things you might want to detect. You know, you could imagine if you had like a group of city names that was like, you know, Winnipeg, Manitoba, and Pinawa, Manitoba, and Ottawa, Ontario. If you want to know whether one of those cities are in Manitoba or not, it's kind of hard to do when the city name and the province name is mixed up together. So what you could do is you could detect to see whether Manitoba was in those names. And there would be other ways to deal with it too, maybe by using that separate function that we talked about before. So it's a really powerful set of functions, and we won't have time to go over all these functions, but I just want to talk about a couple of these functions. So if you type in str underscore, the nice thing about this stringr package is that all the functions start with str underscore. So if you're working with something with strings and you're not, you know, you're having trouble with something, you want to like remove something from the string or detect something from the string or replace something from the string, by typing str underscore, you get a list of all these options. So, you know, if you're wanting to like, you know, remove or replace things, you'd see, oh, there's actually a function for removing a part of a string. So if, you know, for some reason, if you wanted to remove the Skywalker from people's name and insert something else, you could do that with this replace function. One of my favorite functions that's really good to know about, and we won't really go over it too much, but it's this Str Squish function. So if you've ever been working with a column of data and there are some spaces at the beginning of the word or spaces at the end of the word, that can cause all sorts of problems with joining data or matching data, or you just get a whole bunch of, you know, you might get Manitoba, but you might also get Manitoba with a space at the end, or Manitoba with a space at the beginning. And because, you know, computers are very literal, they treat all of those as different. So this str squish function will just remove all those spaces from the beginning or end of a word and tidy up that messiness in strings. So I recommend looking through these. We won't have time to go through all of these, but I'll share a document at the end of this workshop where I've gone through some examples like we did here, see how some of these work, but they're really useful anytime you're working with string data or categories like names or names of cities or whatever it might be. So next I want to take a look at something that causes a lot of problems, and we've already seen it, which is missing values. So let's take a look at, again at, we use this for the visualization workshop. It's this data called the GSS_cat. And it's some survey data. And the nice thing about it is that it has some messiness to it. So you see that there's, each row is from a person, right? This person, the data was collected in the year 2000. They were never married, their age was 26, and so on. And then it also has the number of hours they spend watching TV, I think per day. We could look into it, but I think per day. So we can see that there's some missing values here in this TV hours column. And this is going to cause us all sorts of problems, right? If we want to do something really simple, like, you know, just say, what is the mean TV hours, right? It's just going to return to us an NA. And we saw that before with that Star Wars data. So there's a couple ways to solve this. The first way we can solve it is by doing what we did before. We can include an na.rm or na remove from this mean function. And that's just telling R, remove the NAs, ignore them, don't include those in the calculation of this average. So if we run this, now we see that average can be actually calculated. And this na.remove is an option in basically every statistical function in R. So if instead of calculating the mean, we're interested in the median, nothing has to change. That na.remove is an option in the median as well. Same thing with, say, like SD, the standard deviation. So that's an option that's available to you in every statistical function you might want to use. So that's one way of dealing with the missing values. Another way of dealing with them, and this can sometimes be helpful, is to just, rather than ignore them in a calculation, like the mean or the standard deviation, another option is to just get rid of them from the data set completely. So remove, in the most extreme case, you can just remove any row from the data set that has a missing value. So that's what this drop_NA function will do, is it's going to look through this data set And any single row that has a single missing value, it's just going to remove that row. Now, this is obviously an extreme thing, and depending on your situation, I can't necessarily recommend it. But just so you know how to do it, you can see that now there's no missing values at all in the data set. So you could, continue on and make your plots or make your summaries, or, even if you had, a summary like this after, you could remove the na.remove because now there are no missing values. And you can see that that gets us the same answer as before, at 2.59, right? So that's one way of dealing with them. Another option for dealing with them is to replace the missing values, right? So let's say, for example, we were the developers of the survey and we knew that a missing value in the question to how many hours do you watch TV? Well, if it was missing, that's because the person selected 0. Let's just say that's how the survey was set up. So then in that case, we don't want to ignore the missing values in our calculations. We want to replace those missing values. So let's just take a look here, back at the data. So for example, these missing values here in this TV column, what we want to do maybe is instead of ignoring them or deleting these rows, what we want to do is replace these with, say, a 0. And again, right, that's not something you can always do, but depending on the context of your work, you might be able to do that. So there's this great function called replace NA. And what it lets us do is say the column that we want and then what to replace the NA with. So to do this, what we need to do is type in list. And we won't talk about this too much, but a list is just a particular data structure in R, and you need to use it for this function. So it's just something you have to remember. And then all you have to do is type in the column you want to replace and then what you want to replace with. I can't remember if we need to put this in quotes or not, but let's see. No, it doesn't look like it. Perfect. So now we see that what this has done is it's replaced the NA and it looked at the TV hours column right here. And anywhere there was an NA, it replaced it with a 0, right? And again, this might not be what you want to do, but it's good to know at least how to do it. So if you wanted to then, again, do a summary or something like that, you could do that right here. And you would expect different values for the summary because you're not ignoring these values anymore, but you're actually replacing it. So those are 3 broad ways you can deal with missing values. And again, that occurs all the time with data. So you can either, remove the NAs or ignore them in particular statistical calculations by using that na.rm. You can drop NAs entirely. So if you leave this blank, and this is something that's actually good to mention, if in this drop NA function you leave it blank, that's going to remove any row that has an NA at all. But if you only want to remove rows that have an NA in a particular column, like say TV hours, you can just put that name of that column in that function. And if there are different columns you want to do, so for example, let's say you want to remove the NAs or drop the NAs in the rows for anyone who doesn't have the number of TV hours they watched or their age specified, you can include that. You can include as many variables as you'd like. You can see that works just the same there. And then the third way of doing it is to replace those NAs. And again, depending on what you're trying to do, one of those might be more appropriate or less appropriate than the others, but it's good to know how to do that. So the next thing that we'll look at now, and this is kind of related to this idea of mutating or making new variables. One of the things that you might want to do is, again, so maybe we'll look back at the Star Wars data. And let's say, for example, let's say that we were interested in eye color of the Star Wars characters, right? So, we could do things like, okay, group by eye color. And we want to know if there's, say, a difference in average height for the different eye colors, right? Let's just imagine that this is something we're interested in. We can see that we have a lot of different eye colors here, right? Black, blue, blue-gray, and so forth. And we can see that we have averages, and we can see we have some NAs, so that reminds us that we need to include that NA.remove or use one of the other methods that we talked about before. So if we run that here, now we can see these different values here. And we see that we actually get something called not a number. And this is probably a case where, let's actually see why that would be. So let's see, let's just go Star Wars filter. So it's a problem with the dark hair color or dark eye color. So we'll go eye color equals dark. And we can see what the issue was. So there was only one character that had a dark eye color, and their height was NA. So even though we included that NA dot remove for the mean height, it still can't calculate that, so it comes up as not a number. And this is really good because you can see as we're starting to work with more realistic data sets, more and more little problems are coming up, right? So it's really good to know how to deal with those. So, you know, as an example here, right, we have this not a number here. So we should be able to filter this out using this drop NA. And we could, let's see if this works. Right, and we can see that that did, right? So depending on the situation, you might need to use a combination of these methods. Let's get rid of this here. So let's say we were interested in, again, the average height by eye color. And let's say we have all these different eye colors. And let's say that there's too many eye colors here. So what we really want to look at is the difference between, you know, blue eye color and everything else, right? So let's say we want to make a variable that encodes whether the eye color is blue or whether it's not. And we've already looked to see how to do that a little bit with the string detect, but I'll show you another way to do it and then show you a more realistic example of when you have more categories. So without getting into that too much, let's just take a look here. So let's say we want to mutate, and let's say that we want to do is blue. So let's make a new variable called is blue, and we're going to use this function called if else. And what we're going to do is check to see, and this function if else, if you're familiar with computer programming at all, this idea might be familiar to you, that you're testing to see if something is the case, and if it is, you're going to do one thing, and if it's not, you'll do something else. So you'll see that the first thing this function asks for is a test. So the test we're going to ask, say, is the eye color equals blue, right? And all we're really interested in is if it's exactly blue, not if it's blue-gray or not if it's red and blue, but we want to check if it's exactly blue, right? And that's the reason for using this if-else function rather than using something like that string detect function we used. So what it's going to do is check to see if the eye color is exactly equal to blue. And if it is, we'll see that the next thing it asks for is what to do if it's true. If it's true, we're just going to call that, we'll call that blue eyes. And if it's false, we'll call that not blue eyes. And let's just see if I can. Moving this on my Zoom. Okay, there we go. So let's see here. So now what we have is we've made a new column and we're saying if the eye color is equal to blue, we're going to make that variable called, or you know what, we'll even just call this eye color 2. So we're going to check to see if eye color is equal to blue. And if it is, we're going to say that's blue eyes, and if not, not blue eyes. And we'll just run these first 2 lines here. And again, this is something that comes up all the time. You make a new variable and oh no, it jumps to the end, right? So how do we get that so we can actually see it here, right? So one of the things we can do, and I'll just do this here, we'll just select out the variables we actually want. So you can see how this is, you know, especially when you're working with this real life, you know, messy data like this, you can see how it's sort of an iterative process, right? We're not able to just write, you know, 20 lines of code that do exactly what we need. You write 1 line of code, that solves 1 problem, but creates 3 more. So then you need to go and solve each of those problems. And, you know, with here, when we made this new variable, well, it jumped to the end of our data set, and R is only showing us these first several columns. So we want to get this up to the front, right? So we'll just select, and we'll just keep eye color, the original eye color here, the eye color 2 column that we made, and let's keep height as well. So now we'll run these 3 columns, and let's see if this worked. So here's our original eye column color, or column. And we see we have blue, and this eye color 2, we can see converted that or encoded that as blue eyes, yellow was included as not blue eyes, and so on and so forth. And we see that it even did exactly what we wanted, and the difference between that Str Detect function was here this person had blue-gray, but it correctly identified them as not having blue eyes, because we're only interested in the difference between truly blue eyes and not, right? So now what we can do is we can type this to group by eye color 2, and then summarize height. And again, we'll just drop that NA so that we get rid of that not a number problem. And here we see, again, we have blue eyes, not blue eyes, and we have the difference in heights, right? Now this might be a little bit of a silly example, maybe no one is interested as a research question in, the difference in heights between different Star Wars characters. But these exact same techniques apply to anything that you're going to be doing in R. You're going to be creating new variables. That's going to cause problems. So you're going to have to maybe select the variables you want. You're going to be grouping by those new columns that you made, and then doing summary statistics or plotting with those variables or whatever it is. Now, one thing you could ask is, well, this if-else works good when you're only creating a new variable with just 2 categories, right? So blue eyes or not blue eyes, or is in Winnipeg versus not in Winnipeg, or Manitoba versus the rest of Canada, or that sort of thing. But what about when you have several different categories you want to make? So let's say, we wanted, a blue eyes category, a red eyes category, and then everything else, right? That doesn't seem to work so well with this if else, because that only allows you to test one thing at a time. So there's this function called case when, and it is basically an extension of this if else. So it kind of works the same way. So here, we'll just call this the same thing, eye color 2. So rather than writing if else here to test if the eye color is equal to blue, what we're going to do is write case when, and then parentheses. And I'm just going to hit enter now so that this kind of jumps in a new line, so it's easier to keep track of what we're doing. Now the syntax for this is a little bit different than the if else, but this is a really, really useful function. So it's a good thing to practice with and play around with. So let's say that we want to check, the first thing we want to do is check if eye color is equal to blue. Now that's not any different than what we typed in the if else, but it's going to be a little bit different than how we type what to do if it is blue. So we're going to write this tilde here, and that's just under the escape key on your keyboard, this little squiggle, this tilde. And then we're going to write blue eyes, right? So what this is telling R is check to see if eye color is equal to blue. And if it is, this little tilde, then make this new variable called eye color 2, say blue eyes. Now we'll put a comma and then we'll put our next test in here. So we want to check to see if eye color is equal to red. And if it is, tilde, we're going to say that's red eyes. Okay. And we could keep doing that, different things, and you could even include a combination of things in here if you wanted. So you could test things like, like if eye color is equal to blue and their height is over this, then make a category called, tall with blue eyes, that sort of thing. So you can have as many different tests in there as you want. But for now, we'll just stick with this little bit of a simpler example. So this one tests if the eye color is blue, and if so, it's called blue eyes, red eyes. But then everything else we want to just be not red or blue. We'll just make a category. So to do that, what we're going to do is type true, the tilde, and then called not blue, red eyes. So what this is going to do is it's going to check if the person has blue eyes. If it is, it's going to save this new variable for them as blue eyes. If it's red eyes. And then the true means anything else, right? Not red, not blue. Then we'll make this new variable called not red or blue eyes. And if we run this, we're going to have the same problem again, that this new variable has gone down here. So we'll do select to just keep the variables we need. So we'll go with eye color 2, and we'll keep height. And again, we can see that this worked exactly the way we wanted, right? Blue was blue eyes, yellow, not blue or red eyes, red eyes, and so forth. So now we can do things like if we wanted, a summarize, average height. We'll call this mean height. and we'll put in a group by in here, group by 2. This is getting somewhat long, but we can see what we've done here. And we see that we get those averages, right? And we see that, oh, we still have that same problem with NA, so we'll just include NA.remove and true. So there, right? So if we were interested in this, we could do that. So again, this kind of just comes down to this idea that you often don't have the variables you need to do the analyses you want or to make the plots you want, or if you're using machine learning models, you're not going to have the columns that you need that act as predictors to predict the thing that you're looking to predict. But by using these methods of mutate and if else or string detect or case when, you're able to make those new variables so that you can actually do the things that you want. There's 3 big things that I want to talk about before the end. But before we do that, I just want to show one good trick with this select function. So there's these set of helper functions for using select. So let's say that we're interested in Star Wars still. And let's say, let's take a look at this just to remind ourselves what we have here. And let's say that we're interested in, all of the variables that have, color in it. So we're interested in hair color and skin color and eye color. Is there any other ones with color? No, let's say that's it. So we could do this, what we've kind of done, right? We could type out select, right? Hair color, eye color, and type that all out. But it's kind of tedious and error prone. And if there were, 1,000 variables in this data set and, a dozen of them had the word color in it that we were interested in, it would be very tedious to have to type those all out. So the tidyverse offers this set of what they call helper functions to allow us to select the columns that we're interested in. And the one that we can use here is, we can use this one called ends with, and then we can put color in there. So what this is going to do is look in the columns to see which ones end with the word color. And if we click run on that, we see that we get exactly what we want, right? We've got hair color, skin color, and eye color. Another thing you can do is use this function called starts with. Let's see if there's a good example of Star Wars. If not, we'll look at a different data set. Okay, so we'll use this data set here called Billboard. And this data set has information on artists and tracks that were on the Billboard Top 100 in the year 2000. So let's say that we're interested in all of these columns here that start with week, right? Week 1, week 2, all the way up to week 76, right? You can imagine we don't want to have to type in select week 1, week 2, right? If we were interested in all those week variables. So what we can do is we can just say starts with, and then WK for week, and we can see it only returns those columns that start with week, right? So it allows us to get rid of a lot of columns we don't want or aren't interested in. A couple other functions that are helpful, similar to this, are contains. So if we had something like this, Star Wars, we can also say contains color. And then if color appears anywhere in the columns, then it'll pull those ones out. And in this case, it wouldn't make a difference because column always appears at the end. But if we run that, we can see that it works the same way. It was able to pull those out. So that's really helpful for working with lots of data when you have lots of variables, but you really only need to get down to the ones that you're most interested in. So the last couple of things that I want to talk about are not so much the cleaning aspect of data. So everything we've looked at so far has been kind of cleaning the data, messy strings, or creating new variables, or splitting columns, or joining columns. But often the data you have, it's not so much that it's messy, it's just that it's in the wrong format. So an example of that is when you want to have one single data set to work with, but the data is spread across multiple data sets, right? So if you're familiar with joins at all, this is what we're going to talk about here. So there's these nice little data sets to exemplify this. There's a data set called band members. It's a nice small data set here that just has 3 rows. And there's the name you can see, Mick, John, and Paul, and then the band they're in, the Rolling Stones or the Beatles, right? And there's also this data set called band instruments. And you see that it also has a name column and what instrument they play. And the thing about it is, and this is the common situation when you're working with multiple data sets like this, is you want to join them together so you don't have to juggle these multiple data sets. And we can see that there are a column in each of them called name. So it would be helpful to join that up, right? So for example, here, John is in the Beatles. It would be helpful if we could have a column attached to this that says, plays guitar, and Paul is in Beatles and plays bass. And then of course, there are some situations like, Mick Jagger doesn't play an instrument, he sings. So, that would just be left blank, right? So to do that, we'll just quickly go through how you do these joins. And if you're familiar with joins, this will be something that you're kind of used to. But there's 6 different types of joins you can essentially do in R. So we're going to start with this band instruments. And we'll start with what's called a left join. And we'll talk about what that means very briefly. But what we can do is we can say we want to use this band members data set and left join it with band instruments. And let's just take a look at what that does. And then we'll talk about it briefly. Well, you can see what it does is it's joined these 2 data sets, and it's even told us that it's joined by name. So R is smart enough to figure out what the common names are between these data sets, and it'll join them up. And again, in a situation where there is no instrument in this band instruments data set, it just leaves it blank. Now, we won't have time to go through all of these different types of joins. I'll just write them out, and the document that I'll share at the end of this that will be made available to all of you, we'll go through these in a little bit more detail. But if you're familiar with joins, you'll recognize these names. But there's essentially the left join, the right join. Oops, I didn't mean to put that inside of there. I'll just do this, right? There's the left join, there's the right join, there's a full join, there is a inner join, and then a semi-join, and a anti-join. So if you're someone who joins data together a lot, these methods are probably familiar to you. And if not, like I said, this document will go through them. But really the only thing you need to know about them if you're not familiar with joins is they allow you to take those 2 data sets and link them all up by a common set of columns or a single column. And it's really useful because all of these tools that we've talked about today of like the mutate and these different plotting functions and that we've looked at different workshops, they work best when you have everything in one data set rather than spread across multiple data sets. So by using these joins, they actually allow you to get the data into one data set so it's easier to work with, and you don't have to juggle these different data sets or keep tracks of the links between, a column or a data set about, the members of bands versus the instruments they play. And this has applications for no matter what type of work you do with data, you typically have to join up different data sets, say by a client ID or by a country or by a city or by some transaction number. So it's a good thing to know how to do. The next thing I want to just talk about is, again, this idea that sometimes data is not quite in the structure you need. So imagine, your coworker tells you, oh, I'm going to send you some data right away. And there's data on, people's religion and data on the amount people make for their income. And then it has a count of how many people belong to each of those categories, right? And let's say they say to you, what we want is to get an idea of the count of how many people make a particular amount of money, like $10,000 or whatever it is. So if, what you might imagine that data would look like is something like this, right? You have a column for religion, agnostic, atheist, Catholic, etc. And then you have a column for income. That's these different categories, right? Less than 10,000, between 10 and 20, between 20 and 30, and so forth, right? And then you have a count of how often or how many people are within each of those groups. So there's 27 people who are agnostic who make less than $10,000 in this data set, and so forth, right? So you might you might imagine that the data is going to look like this, but let's say when you get it, rather than looking like that, what it looks like is this. There's this data set called religious income here. And let's say that, it looks like this here. So rather than having a column for religion and a column for income, you have a column for religion, but then income is sort of spread across the columns, right? Now, this makes it really difficult to work with and kind of awkward to work with. So like one thing you could do to get around this, and again, remember, all we really want to do is get an idea of how many people make $10,000, how many people make $10,000 to $20,000, and so on. So one thing you could do is say, okay, I want to summarize, and I want to summarize, the sum or the total of this column. Now, already, because there's these, special characters in these columns, R has put these little backticks in here. So that kind of also makes it frustrating to work with. But we can see here, okay, so there's 930 people who make $10,000 or less. But if we want to do the same thing for $20,000, well, now we got to copy this and say sum, whoops, you can see I made a typo already, sum $20,000. Right, and we could do this for these 10 different categories, but it's very frustrating and it's error prone and it's very tedious. So what would be nice is if we could just convert this data and we could just kind of squish this data down so that we keep that column for religion, and then we have a new column for our income with those different categories, right? So basically, what we want to know is there some way we can reshape this data we're looking at here to look more like this data here, and do that in an easy way so that what we can do is just group by income and then summarize this count or this frequency column, and we'll get everything that we wanted without all that copying and pasting. So the way to do that is with this function called pivot longer. And what this is going to do is it's going to kind of melt that data down from this big wide format to this longer format. And we'll just take a look here. So this function called pivot longer, and it has a lot of options for things that we can do, but we only really need a couple of them. So the first thing we're going to do is give it the columns that we want to take from those column names and then put in their own column. So we'll just write this out and then we'll talk about it, but we're going to put minus religion. And what this is going to do is take every single column and make a new variable with it, but we're going to exclude religion because we want to keep that religion column. And this takes some practicing with. If this isn't, I don't expect anyone watching to sort of intuitively understand this. It takes some practice and messing around with to figure out exactly how to use. But then the next thing it wants is names too. So what that's going to do is say, it's going to take these names and it's going to make them a different column. Or once we take all of these columns, what is the new name we want? And because this is income, we're going to call this income, right? And if we look back here, this is actually, what we have. We have this income column. And this will make more sense once we write the whole thing out. And then the last thing we need, we go all the way down here, is values too. And that is, it's going to take all these values here and it's going to sort of reshape them, and it's going to place them with its corresponding religion and its income. But it just wants to know what we want to call them. So I'll just call this frequency. And if we run this, we'll see that, oops, religion. Yep, that wasn't called religion. Oh, I just made a typo. So run this, and here we see we get exactly what we want, right? So what it's done is it's reshaped that data. So rather than having 10,000 and 10 to 20,000 as columns, it's made that into a variable for us, and it's kept everything in the correct ordering. We can see that agnostic less than 10,000 is 27, and then the next one is 34 and 60. And if we look back at our original data, we can see that we have 27, 34, and 60. So it's kept everything nice and ordered in the way we want it. But now it's put our data into this format that we're used to working with, right? If we wanted to make a plot or to summarize, we can now just say, group by, what did we call that? We call that income, right? Group by income. And then summarize, or maybe we want the sum of the frequency, right? So we want to know how many people are in each of these groups. there we go, right? These were the numbers that we had gotten out before, but we had to copy and paste it. We would have had to copy and paste it nearly a dozen times. But here we get everything ordered in the exact way that we want. And if we wanted to make a plot with this or something, we could do that really easily. So that's basically how you take a data set that they kind of call it a wide format, where things aren't stored in variables, but they're sort of spread across columns, or the values of a particular variable are spread across columns. But you can also kind of have the opposite situation. So say, for example, you want to make a data table that looks like this, right? So you have country here, and then you want to have the year across the top, and then the values inside of it, right? So this is kind of the opposite situation. Before, we started with a data set like this, and then we cast that data set down to that longer format. But what if you have a data set that looks like Gapminder, right? So I'll just type in Gapminder here. So what if we're starting with this data set, right, where we have a column for country and year and life expectancy, but we want to reshape this so that we have a table that looks more like this, right? Maybe we find this a little easier to read, so you can just go across and look to see how life expectancy was changing across time for each country, right? Maybe you find this easier to read. So the question is, well, how do we convert that, right? So before, we did pivot longer to take a wider data set and make it longer. Here, we're going to kind of do the opposite, and we're going to use a function called pivot wider. And if some of this is not quite clear, again, I encourage you to play around with it. And it's enough to know that some of these methods exist, even if you don't know how to use it. When it comes time to use it, then you know how these things exist, or know that they exist, and you can look into it a little more. So again, if we push tab, it's going to say the columns that we want to pivot. So the first thing I'm going to do to make our lives a little easier is select out the columns we want. So I'm just going to keep the columns we need, which are country, year, life expectancy. And then we'll pipe that into this function here. And what we want to do is take in, names from, and we're going to make our names from year, and values from, we're going to take that from life expectancy. And let's see if this works. Yeah, so this works just the way we wanted, right? So what this is doing is, I'll scroll up to our original data. It's taking our year and it's making those our new columns. So it's going to make one column for 1952, one column for 1957, and so on. It's going to leave country as is, and then it's going to put those life expectancy values where they belong here, right? So now we've taken that data set from that long format and made it into a wide format. And again, you need to do that for all different types of reasons. But maybe you want to do that just to make a summary table like this, that maybe it would be a little bit easier to read rather than having it in that long format. And again, I encourage you to play around with these methods because they take a bit of practice and fiddling around with to understand exactly what's going on. The last thing I want to talk about is another really big topic. And again, there'll be more examples in the document that we'll share. But another really big issue comes is when you're working with dates. So what we'll do is we'll load in another package that's part of the tidyverse package, but it doesn't automatically get loaded. So we have to load it in, and it's called Lubridate. And I guess it's a bit of a pun on there, but basically it makes working with dates easier. So if we run this, we'll see that it loaded that fine. And again, that's already part of the tidyverse set of packages. But what this package does is makes working with dates easier. And there's at least two issues when working with dates. The first is that usually every date you come across is always formatted in a slightly different way, right? It might be year, month, day, or day, month, year, or something else entirely. So that's sort of the first problem, is you need to be able to tell R what format that date is in so that it knows how to work with it. And then the second problem you can have with dates is extracting various components of that date. So maybe you have the entire date, right? The year, month, and the day, but maybe you want to extract out the day of the week from that date because you're doing an analysis and you want to know, when particular claims were made, if it was more on a weekday or a weekend or whatever it was. So we'll use some data from this Lubridate package, and we'll just go through kind of quickly, but it's called Lakers. And what I'm going to do is just type in here as Tibble Lakers. And all this is doing is just converting this data frame to a tibble, which is what we're used to working with. It just makes working with this data a little easier. So here we have this Lakers. And you can see that there's a date column in there, but you can see that right now R is representing it as an integer, which is not particularly helpful, right? It doesn't allow us to do the things with dates we want to do. So let me just go here, select, and I'm just going to click date. And you can see how it's storing this. You can see it's storing it as just the number here. So what we want to do is tell R that, listen, don't treat this as a number. Treat this as the year 2008, the 10th month, the 28th day. So to do that, there's a set of functions that are really easy to use. And we'll use mutate, and we'll just make a new date variable. And the nice thing is that no matter how your date is formatted, there's a function to use it. So what we're going to do is and we'll talk about this, but what we're going to do is type in YMD and then date. And just looking at this, you might be able to guess what this means. But what this is doing is telling R, whatever date I give you, which are all these numbers, the first thing it comes up against is going to be the year, then the month, then the date. Now let's run this and see how this works. And now you can see when we run that, R is no longer storing that date column as an integer or as a numeric value, but now it truly understands that that's a date. So now we can do things like do summaries with these dates, or plot them in a proper way, or we can calculate what the smallest date or the most recent date was, or the latest date, do all those things. So that's a good initial first step. If you don't have those dates properly formatted, it's going to cause all sorts of headaches, because when you go to sort the dates or look for the first date or do whatever, R is going to be treating them as numbers or as a character or whatever it is. Now you can imagine if the dates were in a different format, so if it was, month, day, year, well, then you would use a function called MDY. And there's, every combination of function you can be or every combination of those letters that you would need. So all you really have to do is just look to see how that date is structured, and R will convert that to that particular format. And again, R is pretty smart, so if you have things like hyphens or slashes in there, spaces, it'll be able to parse that most of the time and figure out how to deal with that. And the last thing I'll quickly show in working with dates is, it's great to have the date here, but often what you want to be able to do is extract particular components from this date. So maybe you want to be able to extract just the year out, right? So maybe we want a different column that has the year. And we don't care about the month or the day because we're going to be analyzing the data by the year. Well, it's great because there's these functions in Lubridate that allow you to pull out those components. So if I say year date, that's going to extract out the year component, extract out the year component of that date. So now we can see this generates a new column called the year. I'll just move this up so it's a little easier to see. Extracts out a new component called year, and it's done that. We can, and I'll just put this in the same mutate function here, but if we want something like month, I can call that month and then say month date. And if I run this, then it's going to extract out the month, and you can see it's just put a 10 here. And you might say, well, I don't want that to be a 10, I want that to be the actual day of the month as a string. And if we look in this month function and push tab, we can see that there's this option label, and we can just set that to true. We run this, and now it's made that to change 10 to October and so forth. Another option that's available to you here too is you can say abbreviation and then set that to false, and then it'll put that to the full long form of the month. So this is really useful because this Lubridate package in the tidyverse first lets you set that date so that it's actually a date format, so you can do all the things you want with it. And then for plucking out different aspects of that date, it's really helpful. Another one that's really helpful, I'll just quickly show you, is the weekday. So there's this function called Wday. And if you put in the date here, it will extract out the day of the week. right? So 1 is Sunday, 2 is Monday, and so forth. But just like before, we can say label equals true, and it will put those labels in there. And we could change, abbreviation to false to get those full values, right? So that's really nice because when working with dates, like I said, they're always formatted different, and you always need to be able to pull out those individual components. And this Lubridate package really lets you do that. So we've covered a lot, and again, many of these things, depending on the type of data you work with, you might not use, or some of these things you might need to dig in a little bit deeper. If you're someone who's working with dates a lot, looking into this Lubridate package would be really good. If you're someone who's using strings and there's lots of messy text data, then that string R function is really good. And again, all those functions start with str_, so it helps to find them. But I would really encourage you to practice with these methods and look at some of these data sets that we've talked about to really kind of get your feet wet and practice with it. By practicing for a few minutes, you'll be able to, well, you'll make a lot of mistakes, which is really helpful, but you'll learn a lot from those mistakes. And the last thing I'll say here too is that, like I said, we'll share this document that you're looking at here. I'll probably add a little bit more to it before we send it out. But it covers everything that we talked about today here and a lot more. So the review of all these functions, you can see there's a lot of code, and then splitting these columns and doing all that sort of thing. And then the last thing I'll say is that at the end, there's sort of a nice realistic example of how you might use a lot of these things together to clean a data set for plotting. So this example here, putting it all together, I use this billboard data here, but you can see, there's, a couple dozen lines of code here. But, all of these lines of code here are all data cleaning steps, data manipulation steps, or data cleaning steps to make, what is a pretty simple plot. And that is very typical of working with data, right? They say that 80 to 90% of a person's time is just spent cleaning up the data. And certainly when you look at people's code, most of that data, or most of that code, will be cleaning and filtering and mutating and joining and reshaping data just to get something that seemingly is pretty simple at the end of it, like a simple plot or a summary. But that's just because the data in the real world that we work with is often so messy and ill-formatted that unless you know these methods of reshaping and structuring the data, it can be really frustrating to work with data. So again, I would encourage you to look at these methods and spend more time with them, because once you practice with them and they become second nature, it really opens the whole world of possibilities to you, and you're able to work with data that other people just can't work with, because when it lands on their desk, it's not in the right formats and they don't quite know how to deal with it. But by using these methods that we've talked about today, you'll be able to reshape and structure and fix the data so that you can use all these great tools in R, whether that's summaries or visualizations or statistical models or machine learning, or whether you're building applications. You really need to be able to know how to reshape and structure that data. So that's it for today. And I thank everyone for being here. I think we're kind of out of time. Hopefully all your questions got answered, but if not, I will, I can reach out to you and answer your questions, or please feel free to reach out to me, and I'd be more than happy to answer your questions, or to point you to different resources that might be helpful to you. So thank you very much.
Thank you so much, Matt, for that presentation. If there are no questions, which we are out of time, like Matt said, I will end the recording here and end the session. So thank you so much for joining us today, and feel free to look out for more IPAC events that are coming up within the next year. Thank you so much, guys.
Thanks again.